Hi guys, let us see heap sort in this lecture. So the concept of heap sort, it reorganizes an input array into a heap and then repeatedly removes the largest node from that heap, then placing it at the end of the array. Max heap. In a max heap, the value of the parent node is greater than or equal to the value of its children. It ensures that the largest element is always at the root. In min heap, the nodes that have value less than or equal to the value of its children are called min heaps. The smallest node in a min heap is at the root. The heap sort works as follows. Build a max heap from the input array, then swap the root, that is maximum value, with the last element in the array. Then reduce the heap size by 1 and remove the root element and store it from the right end of the array. Then reheapify the heap to restore the heap property. Let us see the example. So the list of elements are given in an array. So for example, 12, 4, 1, 23, 9, 15, 8, 17. So you take the first element 12 and store it as a root element 12. Then this 4 will become left child of 12 and 1 will become right child of 12 and 23 will become left child of 4 and 9 will become right child of 4 and 15 will become left child of 15 and 8 will become right child of 1 and 17 will become left child of 23. That means we have constructed a binary tree, that is complete binary tree. That is the binary tree, each node can have 0 or 1 or 2 children. That is maximum 2 children are allowed in binary tree. So you construct a binary tree from the list of elements as given in this diagram. So next, you always start from the right end and we have to start from the lowest level. So this is the lowest level. So you compare this children, its parent node, that is 23, that is children value is 17, parent node is 23. So 23 greater than 17, that is parent node value is greater than children node, so no swap required. So this level we don't have any other node, so please go to the one level up. So here you compare 8 and 15, which is the highest value, 15. So you compare 15 with its parent value 1. So 1 is lesser than 15. So that means we have to swap because the parent node value should be greater than its children node. So when you compare 15 and 8, 15 is the higher value. So then I compare this higher value with its parent node value. Parent node value is 1, which is lesser than its children value. So we have to swap 15 with 1. So now what happened to the tree? So this is what the latest tree structure. So now we have completed this. Then you move to this level. Here you compare 9 and 23. 23 is greater than 9. Then this take the 23 and compare with its parent value. Parent value is 4, which is lesser than 23. That is 23 is greater than 4. So we have to swap. That means 23 should go to its parent value. So that is what we have to do. So when you do like that, so 23 will go to the parent node. But now after making this change, now we have to compare this 4 and 17. So 4 is a parent node for 17. But what is the rule actually? The parent node value should be greater than its children. So certainly we have to make a swap. That means 17 will go to the this place, parent node place, and 4 will come to the children node. So that is what we have to do. So we have completed this level. So now we compare here 23 and 15. So which is higher? 23 is higher. Now 23 is compared with its parent node. So 23 is greater than its parent node, that is 12. But what is the rule? The parent node value should be higher. So certainly we have to make a swap. So what happened now? So 23 is at the root node. Okay, so when you make a change, this 12 has come here. So now we compare with its children. So 9 and 17, 17 is greater, and 17 is again compared with its parent node 12. So 17 is greater than 12. Certainly we have to make a swap. So 12 will come to this place and 17 will go to this parent node. So that is what we have done. 17 has come here, 12 has come here. So that is what. Now you ensure that all parent node has higher value than its children and root node has the highest value. So if you ensure this, so what you can conclude, we constructed max heap of the tree and we are calling it as a heapify process. So one part of the process is over. That means we have constructed max heap of the tree. Next, what we have to do now, we have to remove the root element and store the value from the right end of the array and bring the last leaf node to the root. That means this is the final tree structure we got it. So you have to remove this root node because in max heap the root node has the highest value. So remove this 23. So 23 is stored in this array from the right end. So we have stored here. In this 23 place, we have to keep the leaf node. So what is a leaf node? The last level. So 4. So this 4 will come to this place. So that is what we have done here. So 4 will come to the place where 23 was there. So now this is removed. This 4 is removed and kept here. But when you come to this tree, again we have to apply this rule. That means you see what is the children value 17 and 15, which is higher, 17 is higher. You compare 17 with its parent node 4, 17 is greater than 4. Certainly we have to make a swap. That means 17 will go to this place, 4 will come here. So that is what we have done. 17 is at the root node, 4 is placed here. But when you place 4 here, then you compare with the children. So 9 and 12, 12 is greater, and again 12 is greater than 4, its parent node. So certainly we have to make a swap. That is 12 will come to this place, 4 will come to this place. That is what we have done here. So 12 is placed at the parent node. So this is the structure we got it after removing the root node 23. So after removing the root node 23, the 23 is stored at the right end of the array. Then we have to apply the max heap process again. So this is the final tree. We got it. So next we are going to take this as a reference. So when you take this as a reference, again the same process. Now remove the root element, store the value from the right end of the array and bring the last leaf node to the root. That means 17 is removed. So when you remove 17, so what is the last leaf from the right end? 8. So this 8 will come to this place. So 17 is removed and stored it in the right end of the array here, and this 8 the leaf node from the right end, this is going to the place where 17 was placed. So this is what the tree we got it. So this 8 is removed and placed in this root node. So when you place 8 here, then you apply the rule 12 and 15, which is higher, 15. When we compare 15 with its parent node, that is root node, 15 is greater than 8. Certainly we have to make a swap. So what will happen? 15 will go to its parent node, that is root node, 8 will come here. So 15 is placed here and 8 is placed here. This is the tree we got it after removing the node 17. So next step, we are going to use this as a reference. So now you take this as a reference, apply the same process, that is remove the root element, store the value from the right end of the array and bring the last leaf node to the root. So we have to remove the 15. So remove 15 and store it in the array. So when you remove 15, so the last leaf node from the right end, so this one will be placed in this root node. So that is what we got it here. When you place 1 here, then you compare with its children. 8 and 12. 12 is greater than 8. Again, you compare 12 and its parent node. So 12 is greater than 1. Certainly, we have to make a swap. So what will happen? This 1 will come to this place. 12 will go to the root node. So that is what done here. 12, 1. But when you place 1 here, compare with its children. So 4 and 9. 9 is greater than 4. Then when you compare 9 and its parent node 1, so 9 is greater than 1, you have to do a swap. That means 9 will go to the parent node and 1 will come to the children node. So this is the final tree structure. We got it after removing the root node 15. So for the next level, we are going to use this as reference. So now you use this tree as a reference now. So now remove the root element and store the value from the right end of the array and bring the last leaf node to the root. So what we are going to remove now? 12. So the root node 12 is removed. So always we are going to remove only the root node, that you should remember. So we are not removing any other node. So we have to remove only the root node. So root node 12 is removed here. So when you remove the 12, so where you are going to store it? From the right end of the array, you are storing it here. So when you remove the 12, so which element will come to this place? The last leaf node from the right end. So again this 1 will come to this place. So this is the tree, we got it. So when you place 1 at the root element, you compare with its children. So 8 and 9, which is higher? 9. Again you compare this 9 with its parent. So 9 is greater than 1. So what you should do? So as per the rule, the parent node element should be greater than its children. So we have to do a swap. So this 9 will go to this root node and 1 will come here. So that is what we got it now. But when we place 1 here, when you compare with each children, but what happens now? This 4 is greater than 1. So again we have to do a swap. So this is the tree, we got it after removing the element 12. So for the next level, we are going to use this as a reference. Again, you take this tree as a reference. Now, remove the root element and store the value from the right end of the array and bring the last leaf node to the root. So the 9, the root element is removed. So always we are removing the root element because it is the highest value in that tree. So 9 is removed and stored in this array. So when you remove the element 9, the last leaf node value, this 1 will come to this root node. So that is what we got it. So when you place 1 here, so it's compare with the children 4 and 8. So the which is higher? When you compare 4 and 8, 8 is the higher value. So now what we are going to do, this children value is greater than its parent node. So always the rule is parent node value should be greater than its children. So 8 is greater than 1. So we have to do a swap. So when you do a swap, 8 will come to this place, 1 will come here. So this is the tree, we got it after removing the element 9. So for the next level, this is the reference. So now this tree as a reference now. So now remove the root element and store the value from the right end of the array and bring the last leaf node to the root. So what is the root value? 8. So we are removing this root node 8 and store it in the array from the right end. So we are coming from the right end. So 8 is placed here. So when you place 8 here, so from the right end leaf node is 1. So this 1 will go to the root node after removing 8. So this is what we got it. So but when you compare this parent node and children node, this 4 is greater than 1. So we have to do a swap. So 4 will go to the parent node, that is root node, and 1 will come here. So when you place it like this, again you apply the rule, remove the root node 4. So 4 is placed from the right end of the array, that is placed here. So when you remove 4, finally there is only one node, that is value 1. Then 1 is also placed from the right end of the array. So now you see this list, it is in the ascending order. So this is what the heap sort process. So what is the time complexity of heap sort? So the best case, average case and worst case is order of n log n. So that is the time complexity of the heap sort.